Machine learning is everywhere from spam filters to self-driving cars. But even smart models make dumb mistakes. Why? Because machine learning is full of hidden traps. Let's uncover a few that often go unnoticed but can break your model without warning. First, overfitting. This happens when your model memorizes the training data instead of learning general patterns. It performs perfectly on what it's seen but flops on anything new. It's like a student who aces practice tests by memorizing answers, not by understanding the material. Overfitting gets worse with noisy data, small datasets, or overly complex models. Then there's memorization without true understanding. Models can latch on to surface-level patterns that aren't actually meaningful. For example, a wildlife classifier might decide that animals with snow in the background must be polar bears. That works until it sees a white dog in the snow. Next up, distribution shift. You train your model on one kind of data, but in the real world, it sees something different. This could be a covariate shift, like using a model trained on sunny weather to predict in snow, or a label shift, where the distribution of outcomes changes. There's also concept drift, where the underlying rules evolve over time, like user behavior on a shopping site. Outliers and data quality are another headache. A few strange or mislabeled examples can throw off your whole model, especially if they're weighted too heavily. And low-quality data isn't always obvious. It can sneak in through corrupted sensors, human labeling errors, or biased sampling. Even if your data is clean and your model looks good on paper, metrics can be misleading. Accuracy might not reflect the real cost of mistakes. In fraud detection, missing one bad transaction might be much worse than flagging 10 good ones. That's why we use metrics like precision, recall, and F1 score, and even those depend on using the right test set. There's also the real-world challenge of deploying models. A massive neural net might do great on a server, but what about running on a smartphone or embedded device? You might need to simplify the model, reduce precision, or rethink the algorithm entirely. And finally, learning never stops. Many models are trained once and left alone, but environments change. Sensors degrade, traffic patterns shift, user preferences evolve. That's why continual learning and regular model updates matter. So yes, machine learning can be powerful, but only if we recognize its blind spots. Watch for overfitting, distribution shifts, spurious patterns, unreliable metrics, and practical limits. Good models aren't just trained, they're tested, monitored, and improved over time.
I think I'm falling for you.